Okay, so this is going to be the final video related to the maths syllabus. Okay, so when we've done this, we have finished the maths A-level syllabus. Then we'll be moving on to obviously a little bit of revision and then on to further maths. So it's quite exciting that we've reached the end, as it were. So we're finishing off with differentiating and integrating vectors in the context of displacement, velocity and acceleration. So if I have a displacement vector in the form r equals xi plus yj, so r is our displacement vector, x and y are functions, then velocity, which is obviously the derivative of my displacement vector with respect to time, we call this r dot, and that is equal to x dot I plus y dot j. So this dot notation is shorthand notation for differentiation when we're talking about in respect to time. So you wouldn't use it normally, but with respect to time, we can use it that way. And acceleration, which is the derivative of velocity with respect to time, we can write this as our double dot is equal to x double dot I plus y double dot j, where this is the second derivative of this function. It literally just means differentiation. We differentiate the coefficients of I and j, and that is literally all we do, okay? So that's why there's only one example of the differentiation one. So I'll do that example now. So a particle P of mass 0.8 kilograms, I'm going to write that down here rather than referring back to the question, is acted on by a single force F. Relative to a fixed origin O, the position vector of P at time t seconds is r meters, where r is 2t cubed I plus 50t to the power of minus a half j, where t is greater than or equal to 0. A, find the speed of p when t is equal to 4. Well, to find speed, we need to find the velocity. So velocity is r dot, so it's the derivative of this, so 6t squared I, the derivative of this, so minus 25t to the minus 3 over 2 j. So I've just derived my coefficient of I and my coefficient of j. So I need to know what the vector is when t equals 4. So when t equals 4, r dot is equal to, so I'm just going to substitute 4 into this vector, because I can't find the magnitude of it in terms of time. I have to find the magnitude at a specific value of time. So 6 times 4 squared, 96 I minus 3.125 j when I've substituted in t equals 4. So now for speed, I can find the magnitude of that value. Which is 96.1 meters per second to 3 significant figures. Part B, find the acceleration of p as a vector when t equals 2. So the key thing here is it says find the acceleration as a vector. So acceleration is r double dot, so it's the second derivative of r. So that's 12t I plus 75 over 2 t to the negative 5 over 2 j. So we want it as a vector when t is equal to 2. So r double dot is equal to 24i plus 6.629 dot 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 j. Could have rounded this to 3 significant figures, it doesn't matter. The only reason I haven't is because I know that I'm going to use it in the next question. Part C. Find f when t is equal to 2. So F is mass times acceleration. So F is going to be 0.8 multiplied by the acceleration vector, because that is the acceleration at t equals 2. So therefore the force is 19.2 I plus 5.30 J newtons to 3 significant figures on each component. So remember, a force obviously can go in a particular direction, so it's going in this direction, but the force is this direction newton, so it's that size in that direction. Okay, so that is differentiation. Integration. Integration is effectively the same, but backwards. So you're going to, V is going to be the integral of A with respect to time, and R is the integral of V with respect to time. So we just differentiate the coefficient, integrate the coefficients, and that is it. The only difference is that our constant C is also in vector form. So that is the only real difference here with these questions. So we've got 3 examples, just because they're being a bit more interesting with the style of questions they're giving you. So, a particle P is moving in a plane at time t seconds. The velocity v meters per second is given by v is 3t I plus half t squared j, where t is greater than or equal to 0. When t equals 0, the position vector of P with respect to a fixed origin O is 2i minus 3j. So when t equals 0, R, which is the position vector of P, is equal to 2i minus 3j. Find the position vector of P at time t seconds. So the position vector is going to be the integral of V with respect to time. So it's the integral of 3ti plus half t squared j with respect to time. So 3t, when I integrate it, is going to be 3t squared over 2i. Half t squared is going to be a half t cubed over 3, which means it's going to be 1/6 of t cubed j, and then obviously plus our constant. So I know when t is equal to 0, r is equal to 2i minus 3j. So t equals 0, 2i minus 3j is equal to, well, when t is equal to 0, that would be 0i. When t is equal to 0, that would be 0j. So therefore, C must be equal to this, because all the other parts are 0. Therefore, R is equal to 3t squared over 2i plus 1/6 of t cubed j. I'm going to move that away because I don't know the way of my writing. Plus 2i minus 3j. Now, obviously, we don't want 2 lots of I. For goodness sake, I've looked at my pens and I've got pen marks over my arm. Anyway, I want to combine the i's and combine the j's. So therefore my final answer is going to be 3 over 2 t squared. Well, I've written it differently, don't know, just however, it doesn't matter. Plus 2i plus 1/6 of t cubed minus 3j. So it's just dealing with vectors in this sense. We're just differentiating things separately, that's all. Sorry, integrating things separately, that is all. Okay, example number 2, and I apologise, I keep yawning, my asthma is affecting my chest today. And when I have a bad asthma, I can yawn a lot, so I apologise. It's very rude in the video. It's not that I'm bored doing the video, so I apologise. Okay, the particle P is moving in a plane so that at time t seconds, its acceleration is 4i minus 2tj meters per second squared. When t is equal to 3, the velocity is 6i meters per second, and the position vector is 20i plus 3j meters with respect to a fixed origin O. Find the angle between the direction of motion of P and I when t is equal to 2. Well, the direction of motion is its velocity vector, because velocity is the motion. So velocity vector is our direction of motion vector. So v is the integral of a with respect to time. So it's the integral of 4i minus 2tj with respect to time. So v is equal to 4ti minus, so it'd be 2t squared over 2, so it'd be t squared j plus c. When t is equal to 3, I know that velocity is 6i. So 6i must be equal to 12t minus 9j plus c. So therefore c is equal to, sorry, that should say 12i. So 6i minus 12i is minus 6i. And then I'd rearrange it, I'd add 9j. So therefore my direction of motion vector, my velocity, is, oh, that's what I've written, because I've written I there, is 4ti minus 6i, so 4t minus 6i. And I'm going to do it with a plus, because I prefer to have a plus. So plus 9 minus t squared j. So rather than actually writing out the line I've put c there, I've actually just combined them together in one go. So I want to know the angle between the motion vector when t is equal to 2. So when t is equal to 2, our velocity vector, or our motion vector, 8 subtract 6 is 2i, 9 subtract 4 is plus 5j. So this is our motion vector. This is our angle between I. So it's, if I was to draw a right angle triangle, 2 and 5. So tan theta is 5 over 2. So theta is arctan of 5 over 2, which is 68.2 degrees to 3 significant figures. Okay. Part B for that example. Find the distance of P from O when t is equal to 0. So if I'm finding the distance, then I'm going to need the position vector. So S is the integral of velocity with respect to time. So it's the integral of 4t minus 6i plus 9 minus t squared j with respect to time. So therefore S is, so it'd be 4t squared over 2, which would be 2t squared minus 6t lots of I, plus 9t minus 1/3 of t cubed j plus c. So I know when t is equal to 3 from the question, S is equal to, or if I can read the right question, 20i plus 3j. So that is equal to, so this ends up with 0i plus, this ends up with 18j plus c. So therefore c is equal to 20i minus 15j. So therefore our displacement vector, if I combine my i's together, so 2t squared minus 6t minus 20, sorry, plus 20, I, plus 9t minus 1/3 of t cubed minus 15j. So I want to know the distance of P when t is equal to O. So t is equal to 0, not O. So my displacement vector Is it labelled S? No, it's not. So that should obviously all be R, not S. I think it's because it said, no, I didn't even say speed. I don't know. That should just be R. That's me just knowing its displacement. So I've written S rather than R in my question. So I apologise. That should all be R. So R is equal to, so that'd be 20I minus 15J, which makes sense. It would just be our constant at time equals 0. That generally would be the case. Because I want distance, not displacement, I need to find the modulus of R for our distance. So the modulus of R is 25 metres. So the distance of P from the origin when T is equal to 0 is 25 metres. I think if you put S rather than R, you probably would be fine in the exam. I don't think they would mark you down for that, because you're technically right, it's just we're talking about a vector displacement. But I'd say they're doing it in that way. I'm not really sure, because displacement is a vector quantity anyway, so why it has to be written in a different form, don't ask me. Okay, final example. So this is the final example of the Maths A level. So that in itself is quite exciting. Anyway, the velocity of a particle P at time t seconds is 3t squared minus 8I plus 5j meters per second. When t is equal to 0, the position vector of P with respect to a fixed origin is 2I minus 4j meters. Find the position vector of P after t seconds. So I'm obviously going to integrate V with respect to time to give me R. So we've got 3t cubed over 3, so that would become t cubed minus 8t I plus 5t j plus c. So when t is equal to 0, R is equal to that. Well, this will become 0, this will become 0, so therefore c must be 2I minus 4j. So therefore R is t cubed minus 8t plus 2 I plus 5t minus 4j. So that is the position vector of P after t seconds. So because it's in terms of t, obviously we need the general formula. Part B. A second particle Q moves with constant velocity 8I plus 4j meters per second. So rather than just calling it V, I'm going to call it VQ is equal to 8I plus 4j meters per second. When t is equal to 0, the position vector of Q with respect to a fixed origin is 2I. Prove that P and Q collide. So if P and Q collide, then P must be equal to Q for some value of t. Okay. In further maths, I assume, and they could even in this question when they're talking about vectors, they may say show that these lines intersect, so that they show that things collide, and you would show that they have a shared value. Or it might actually say, do they collide? And you've got to find whether they have a shared value of t. If they all have different t's, then it means that they're equal to each other at different times, which in reality doesn't make sense. So therefore they don't actually meet, because they're equal to each other at different points in time. So we are proving that they're equal to each other at a specific point in time. So I need the position vector of R, because obviously that's where they are. So if they meet, their position vectors will be equal to each other at one point. So my position vector of Q is the integral of the velocity of Q with respect to time. So the integral of 8I plus 4j with respect to time. So my position vector of Q, 8ti plus 4tj plus c. So at t equals 0, r is 2i. Well, that'll be 0, that'll be 0, so therefore c is 2i. So therefore my position vector at Q is 8t plus 2 I plus 4t j. So if they collide, P must be equal to Q. So therefore, t cubed minus 8t plus 2i plus 5t minus 4j must be equal at one point to 8t plus 2i plus 4tj. So that means that I position and their j position must be equal to each other, because they're in the same position on the x-axis or the y-axis and the same position on the j or y-axis. So t cubed minus 8t plus 2 must be equal to 8t plus 2. So they must be equal to the coefficients of each other. So t cubed minus 16t is equal to 0. T is equal to t squared minus 16 equals 0. So therefore t is equal to 0 or t is equal to 4. Obviously plus 4, we don't have a negative time. And we also can say 5t minus 4 must be equal to 4t. So t is equal to 4. So they have a shared value of t. So P and Q, therefore P and Q collide because they share a value of t. They collide at t equals 4 seconds. So that is it. That is the A-level course done. So I'm going to set you a range of tasks over the next week, which will largely involve particular practice of all the applied stuff that you've done, as well as pre-setting you some revision work of pure, so that in a couple of weeks' time we can actually start the further maths course, which is really, really exciting. Obviously remember to ask me any questions, send me an email, send me a message and show my homework, for anything you're stuck on, and obviously I'll help you.